Hello everyone, welcome back. So we will be doing sums related with trigonometric identities, proving of trigonometric identities like this one from exercise 8.3, question number 3, which is sec A plus tan A 1 minus sin A. So I have already posted one video. How do we solve this kind of sums? And I had given the hint there that whenever we have a sum like this where we have to prove this trigonometric identity equal to what, we have to always use the hint, and that is whenever cosec theta is there or cosec A is there, we have to convert it to 1 by sine A. Whenever sec theta or A is there, we have to convert it to 1 by cos A. And whenever tan is there, we have to convert it to sine by cos. And whenever cot, trigonometric ratio cot is there, we have to convert it to cos by sine. So that video I will be sharing it in the description. You can go and check that video as well. And one more thing, so whenever we have a cosec, we have to change it to 1 by sine. Sec, we have to change it to 1 by cos. Cot, we have to change it to cos by sine. Tan, we have to change it to sine by cos. So this is the hint. And whenever we have sine square, we have to think about the identities. So there are three more identities which I have discussed about them in the earlier video. You can first check that video. Okay. So let's start solving this sum. So as discussed, whenever we have sec, we have to first convert it to 1 by cos. So let's convert sec to 1 by cos here. So we can write this sec as 1 by cos A, and tan A I can change it to sin A by cos A. And the other one, 1 minus sin A, I will keep it as it is. We know that sin A can be written as 1 by cosec, but we will not convert sin A to 1 by cosec. We will just keep it as it is. We will keep sin as sin only. Only if cosec is there, then we can write cosec A as 1 by sin A. So whenever sine and cos is there in this kind of sum, we just leave it there. But when sec is there, we convert it to 1 by cos. Whenever tan is there, we convert it to sine by cos. And sine, we leave it as it is. So now what do we do? The next step is, this looks like a fraction. It's in the form of, let's say, 3 by 2. And the other one also looks like a fraction, which is in the form of 1 by 2. So generally, whenever we have fraction and addition is there, we do LCM. And if the denominator is same, the LCM is the same quantity. So if 2 is the denominator here, 2 is the denominator here, and if you are doing addition or subtraction, then the LCM will be 2 itself. Same way, cos is here, so the LCM will be cos A itself. And if we come back and see here in numbers, so when 2 is the LCM, according to LCM rule, we write the numerator as it is, into, we divide the LCM by 2, we get 1. That's how we get 1 there, and we write the numerator as it is, then we divide the LCM by the denominator, we get 1. So that's how we got 3 plus 1 by 2 in numbers whenever we have fractions. So if you see, when the denominator is same and when we do addition or subtraction, the numerator also remains same thing, means there is no change. 3 remains 3, 1 remains 3, remains 1, and we just have to put the sign, whether it's addition or subtraction. So if I follow that here, so LCM is cos, that means the numerator will remain same, it will be 1 plus sin A, and 1 minus sin A was already there. Now what we can do is, if we see again in the numerator, sign is there, so we can't take the help of relation of the ratios and write 1 by cosec. Again, if you see the denominator is cos, so we cannot take the help of trigonometric relation of the ratios and convert cos to 1 by sec. So what do we do now next? So the next step we can take, or we can do, is we can take the help of algebraic identities. And that is, whenever we have a situation like this in algebra, a plus b into a minus b, what do we do next? And the next thing is, we write a square minus b square, which is the identity. Or we can just open the bracket also by multiplying a with this whole quantity and by multiplying b with this whole quantity. Eventually we will get this answer only. So it's better we use the identity whenever we have a plus b, a minus b, and this one also looks like a plus b, a minus b. So the answer will be a square minus b square divided by cos a, because the denominator remains same, no changes. So please note down the steps, copy as I am doing, then you'll be able to understand much better. After this, if you see, 1 square will become 1 and sine square will remain as it is, divided by cos a. So as discussed earlier, whenever we have sine square, we will think about the identity. And where have we seen this 1 minus sine square a? And we know that 1 minus sine square a is nothing but cos square a. From where it came? It came from this identity. Sine square a plus cos square a is equals to 1. So if we shift sine square a to the right side, then cos square a will be equal to 1 minus sine square a. So hence in place of 1 minus sine square a, we can write cos square a divided by cos a. And what is the meaning of cos square a? It means cos a 2 times. Cos a into cos a, and one cos a is in the denominator, and when we have two same quantities in the numerator and denominator, we can cancel one of them. So the final answer is cos a. So I hope you understand. If you haven't understand, you can put a comment. I'll help you out again. Now let's see one more sum similar to this one, again from the same exercise. So let's take the other sum. So if you want to know, or if you want to do trigonometric identities properly, then you need to first understand what is the relation of the ratios, and you have to know what are the trigonometric identities, the formulas and the hints. Then only you'll be able to do the sum properly. So let's see again exercise 8.3, number 3, number 2 question. And the question is 1 plus tan theta plus sec theta bracket 1 plus cot theta minus cosec theta. So this is the question. So I'll show you how we will do this sum. So generally in this kind of question, it will be, they'll be giving you proof that this is equal to some other quantity here, maybe some trigonometric ratio, some value. But in this case, they've just said this is equal to some options. If you see the book, and the options are A 0, B is 1, C is 2, and D is minus 1. So the main thing is how we approach this kind of sum. That is what we are trying to learn here in this class. So whenever you have a sum related with trigonometric identities or trigonometric ratios and we have to prove them, then we have to always remember those points that whenever cosec is there, I'll convert it to 1 by sine. Whenever sec is there, I'll convert it to 1 by cos. And whenever I see tan, I'll convert it to sine by cos. And whenever I see cot, I'll convert it to cos by sine. So these 4 points you have to always remember whenever you do any sum related with trigonometric ratios and proving of this trigonometric identities. These 4 points are very, very important because once we see the sum, the next step is only this. Whenever cosec is there, we write 1 by sine, tan is there, sine by cos, cot is there, cos by sine, and sec is there, 1 by cos. So let's start the sum. Okay, 1 minute. Okay, I'm just removing the options for a while. Let's start the sum. So what we have to do here is we'll write 1 as it is. Now this tan we have to write as sine theta by cos theta. That is what the hint tells us. We have to write the sec as 1 by cos. Then only we will reach the answer. 1 plus cot theta we have to write as cos theta by sine theta. In every sum, whenever the ratios are there, if square is not there, if square is there, then we'll think about the identity. And cosec is there, we will write it as 1 by sine theta. Okay. So now what we will do next is, if you see, it looks like a fraction. So whenever we have fraction, the next step that we do is we go for LCM. And it is just like I'll always bring numbers to understand what we are trying to do here. Then it will give you an idea. So bringing numbers as in, if you see, like supposing if we have 1 plus 1 by 2 plus 3 by 2. In this case, what will be the LCM? LCM will be 2 because 2 is here, 2 is here, and what is here? Below 1. It is 1 only. So the LCM will be 2, and according to LCM rule, it will be 1 into 2 because we write the numerator as it is and then we multiply the numerator with the number which we will get after dividing the LCM by the denominator. So when I divide the LCM by the denominator, which is 1, I get 2. So that's how I got 2 there. Plus here I will write 1 because 1 was there in the numerator into what will come after divide the LCM by 2. And if I divide the LCM by 2, I'll get 1 again plus 3 because 3 was there in the numerator into what will come. I have to divide the LCM by 2. So that's how 1 came. So take the help of these numbers to do this. So if I use follow that point, here 2 was there, 2 was there, and here 1 was there. Cos is there, and here 1 is there below. So the LCM has to be cos. And according to this point, cos will go up. It will become 1 into cos theta, which is cos theta. And if you see here, 1 and 3 remains as it is. So sine theta will be written as sine theta and it will be 1 here. So it's the basic of LCM. Same way we can do LCM here and I'll get sine theta. Sine theta will go up here. It will be 1 plus cos theta minus 1. So this will be the second step because whenever fractions we have to do LCM. That is the only step that will take us to the other step. All right. Now after this what we can do is This is three terms and this is three terms. Actually, we can take the help of this product of three terms, means product of trinomial, which is a x plus y plus z and a plus b plus c. And product of trinomials tells us that x into a plus b plus c plus y into a plus b plus c and plus z into a plus b plus c. But that will be quite long, so we will try to see can we do something else. We can do this way, but we'll try to see can we do something else. So what we will do is we'll do a small arrangement here, and we'll write sine theta first, just commutative property, shifting this one here and this one here. Sign will not change, so sine theta plus cos theta, I'll keep them together in a bracket, plus 1. By doing this, I'm not changing anything. I'll bring another bracket, curly bracket here. Same way, I'll keep sine theta and cos theta in one bracket, and minus 1 I'll keep it separately. And what will happen in the denominator is cos theta and sine theta will be multiplied. It's just like when you have a fraction 1 by 2 into 1 by 3, then what is the final answer? It is 1 by 6, because 2 3 is the same way. Cos theta into sine theta is cos theta sine theta. So I hope till here you have understood. So you can copy it down, then only you'll be able to understand. So now let's move to the next step. After this, the next step that will be, we need to see the numerator properly. Every step we have to be very careful. So if you see the numerator here, it looks like one of the algebraic identities, and that is, which is very common, which we always use. If you see properly, it looks like this whole thing looks like a plus b, and this whole thing looks like a minus b, means it basically looks like a plus b bracket a minus b, and we are considering a to be sine theta plus cos theta, this whole thing as a, plus b we are considering 1. Again, sine theta plus cos theta is a and b is 1. So a plus b a minus b formula is a square minus b square. So let's use that. So if we are considering this sine theta plus cos theta whole thing to be a, then according to the formula it should be a square minus b square, and denominator will be cos theta into sine theta. So see how we have used the identities, algebraic identities. So we need to know few of the things from before, like algebraic identities, algebraic formulas. We might use it anyway. Okay, so after this, what we can do is, now sine theta plus cos theta, it is just like a plus b, we can't add and square is there. So when you can't add and square is there, the only way to open the bracket is again use another identity, which is a square 2ab plus b square. So let's use that. It will be a square plus 2ab plus b square, and this 1 square is 1, divided by cos theta into sin theta. Now what will happen is, now we will take the help of the trigonometric identities, the formulas that we learned earlier or in the previous video. That means when I combine sine square theta and cos square theta together, we know that sine square theta plus cos square theta will give me 1. So I'll keep them together. And finally, sine square theta plus cos theta will give you 1 plus 2 sine theta plus cos theta minus 1. So we should know that sine square theta plus cos square theta is 1. So that also we should know. And this 1 and minus 1 gets cancelled. So we are finally left with 2 sine theta cos theta divided by cos theta sine theta. And whenever we have Same quantities in the numerator and denominator, we can cancel it. Cos theta, sin theta, sin theta. So the final answer is 2. So that's how we have done this sum. You must have seen the previous question and this question, which hint we have used and how we have approached the sum. So if you have understood the video, please inform it to me in the comments. And if you want more questions from this chapter to be done, please let me know which are the questions or which questions you are having problem. I'll help you out with that. So thank you very much.